Hi everybody, Brian O'Connor here. What we're going to have a look at in this bite-sized video is we're going to look at layer 4, the transport layer. And this is part of the OSI 7-layer network model. So we'll have a look at what it is. We'll have a look at these things called port numbers, so why port numbers. We'll look at some well-known port numbers, and there are quite a few of them. We're just going to have a look at a very small subset. We'll have a look at what devices live at the transport layer. So if we have a look here, it's part of the 7-layer network model. It's midway up, it's transport layer. And what is it? So the first three layers that we've covered in previous bite-sized videos of the OSI model are primarily concerned with actually getting ones and zeros, creating frames, datagrams, and moving them between nodes and networks. At the transport layer, we sometimes call this the end-to-end or host-to-host layer. The content of the packages starts to become very significant because this is, I suppose we could say, the real data applications that we're sending backwards and forwards. So we're constructing these application bits of data and we're sending them backwards and forwards between devices. And any given host on the network will be communicating with many other hosts using many different types of networking data. One of the critical functions of the transport layer is to identify each type of network application by assigning a thing called a port number. For example, data from the HTTP web browsing application can be identified as port 80 or port 443 if we're using HTTPS, while data from an email server will be Simple Mail Transfer Protocol, and that may be on port 25. Also at the transport layer, on the sending host, data from the upper layers is then packaged as a series of layer 4 protocol data units. We refer to these as segments, and each segment is tagged with an application's port number. Segments then pass the network layer for delivery, and the host could be transmitting multiple types of packets. For example, it could be web packets, it could be email packets, and it could be doing this at the same time. These are then multiplexed by using port numbers on the same network link if we only have a single network adapter and a single IP address. Actually, each host actually assigns two port numbers. On the client, the destination port number is mapped to the service that the client is requesting, and the client also assigns a random source port number. The server then uses the client-assigned port number as the destination port number for its replies and its application port number, for example port 80, as its source port. This allows the host to track multiple conversations for the same application protocol. When the data gets to the destination, what we then do is we then take that data in and we then demultiplex it, because again we may be passing data to multiple applications. Other things that we have at the transport layer is the transport layer is also responsible for reliable data delivery. So should the application require it, reliable delivery means that any lost or damaged packets are then resent, and the transport layer can overcome the lack of reliability in the lower level protocols. So why port numbers? Why port number? So in the case of the little diagram I have here, I have a server. I've got a very big network adapter in this server. And in this server, it is a web server, it is a mail server, and it's an FTP server. So based on all of that, potentially we're going to be sending multiple types of application data across a single network link. So it's the ports that identify the application. And by combining the IP address and the port, we can then identify the application. So if we take, for example, that this device has an IP address of 192.168.1.1, and the application is a web application, and it's using HTTP, HTTP uses port 80. So what we're doing at this point here is we're using port 80 to communicate that data. That will create 192.168.1.1, then a colon and a number, 80 is the port number. The mail application, again we're still using 192.168.1.1, but we're using Simple Mail Transfer Protocol, and at this point here we're using port 25. So that generates 192.168.1.1 colon 25. Some well-known port numbers that you may be using within your internal networks. So if we're using FTP, File Transfer Protocol, we'll be using port 20 and 21 because we have data and we have control. HTTP, our Hypertext Transfer Protocol, using port 80. HTTPS is secure Hypertext Transfer Protocol, that's port 443. SMTP, our Simple Mail Transfer Protocol, or Transport Protocol, port 25. POP3, which is Post Office Protocol, generally used for receiving email, port 110. IMAP4, Internet Messaging Application Protocol, so is 143. And then we have RDP, which is our Remote Desktop Protocol, which few of you may be using for doing remote sessions on a server, for example. That's going to be on port 3389. We do have some devices that live at layer 4, so we may have a multi-layer switch. So the multi-layer switch is usually working as the next thing down, a network load balancer, but it could also be used as an advanced firewall, and it could also be used as an intrusion detection system. And that's the end of this very short, brief, bite-sized video relating to the transport layer devices. So please stay safe. Hope this has been of some use, and thank you very much for watching.